If a surface is generated around a rotation axis, every section taken perpendicular to that axis should show a circular form. Examples of such surfaces include shafts, holes, circular sections of conical surfaces, equatorial or transverse circular sections of spherical surfaces. In each of these sections, the ideal form is a circle. Circularity defines how much this circular form is allowed to deviate. Circularity is the requirement that a circular section of a part, taken in a plane perpendicular to the axis of rotation, must lie between two concentric circles. These two circles are the inner circle, the minimum boundary, the outer circle, the maximum boundary. All points of the actual surface must remain between these two boundaries. They can neither go outside the outer circle nor inside the inner circle. The distance between these two circles, that is, the thickness of this region, is the circularity tolerance value. What does circularity control and what does it not control? Circularity controls form deviations in the section plane. This includes errors such as out-of-roundness, lobing, and waviness. It does not control diameter/size tolerance, axis location or axis offset, shape consistency along the entire surface. This is controlled by cylindricity. When applying a circularity tolerance, a plane perpendicular to the axis of rotation of the surface is selected. The projection of the actual surface in this plane forms a curve. The entire curve must remain within two concentric circles. The distance between the circles is the specified tolerance value. This tolerance evaluates only the form of a single circular section, and all sections must satisfy this condition. How is circularity measured? 1. V-block plus dial indicator. The shaft is placed on a V-block, rotated by hand, and the probe scans the surface. The difference between the maximum and minimum readings on the indicator is the circularity value. 2. Precision rotary table and indicator. The part rotates on a precision rotary table, the probe remains fixed. This provides a more stable result and is less affected by axis misalignment. 3. Coordinate measuring machine (CMM). A large number of points are collected on a section. An ideal circle is mathematically constructed from these points. Deviations are calculated by the software. It is the most reliable and most repeatable method. There are also special machines designed specifically for measuring circularity. We will cover the details of these instruments in later metrology episodes. Functional effects of circularity. When circularity degrades, the following problems appear. Bearing surfaces move in a wavy manner, vibration increases. Sealing is lost. Balance is disturbed in rotating systems. Load distribution becomes uneven on press-fit surfaces. Noise and wear increase on high-speed shafts. The smaller the circularity tolerance, the quieter, more stable, and more efficient the system will run. Common mistakes in circularity. 1. Confusing circularity with cylindricity. Circularity controls a single section. Cylindricity controls the entire surface. 2. Interpreting axis shift as a circularity error. Axis offset is not a form error. 3. Adding unnecessary datums. Circularity is a form tolerance. It is not reference to a datum. 4. Forgetting that V-block measurements can be affected by axis misalignment. A real example. On a hydraulic shaft, there is a constant oil leak. The dimensions are correct, surface roughness is acceptable, and straightness has been controlled. The real problem. The circularity of the shaft surface should be 20 micrometers, but it is 45 micrometers. Even this small waviness is enough to prevent full contact with the surface. When the tolerance is updated, the leak disappears completely. Friction decreases. Shaft life increases significantly. To summarize, circularity guarantees the correctness of the circular form on rotating surfaces. It is not a control of size, axis, or position, it controls only the form and section. In the next episode, we will move on to cylindricity, the volumetric counterpart of circularity. Follow the series and don't forget to subscribe. The right tolerance, the right behavior, the right performance.